5 pages because somebody hacked this. Let's not create a new one.
I think the catch here is that I had to mute the whole YouTube thing, otherwise sound gets into
Yeah,
the way.
5 pages because somebody hacked.
That's exactly.
Ah.
There we go.
Hi, everyone, by the way.
Hello.
Hello?
Hey.
It's Kelvin talking.
Go back to Zoom.
Go back to Zoom. Okay, we're still trying to set it up.
No problem.
Where is it? There we go. Should I just stop sharing?
No, but you could, so here's where you would control it just like normal. If you mute it, you can stop the video.
But if I don't want to share anything, so what am I supposed to do?
Oh, well, if you don't want to share anything, then you would stop sharing here.
Which
And then you
is
could-
Bottom middle.
Yeah, and then you could mute. If you're
Good.
Not ready.
Sorry, Kelvin.
This just
No,
says,
no problem.
All right. So
Can you hear us
yeah,
okay?
can you hear us?
I can hear you just fine. Yeah.
We'll do a background test.
Yeah, let's do back room test.
I
Let's see if
assume
we
we're
can
not
hear you.
expecting more than these 2 rows while these are still up. Can you hear me okay over here?
I can hear.
I'm surprised. Because
Wow.
I can hear the air conditioner.
I'm gonna go back up to the yell at Kelvin.
You hear me? Kelvin?
I can hear, but probably just barely.
I can't hear him.
So that's picking up well.
So how do you make the volume on for people sitting in the back?
It's on this, so it's on the computer.
So
Just the manual way of doing it.
I think you heard me, Kelvin, but I couldn't hear you. So the
Okay.
speakers are.
right next to you. So
And there is another volume on here if you must.
These are micro speakers, so.
With a sub.
Yeah. Oh, there.
It
Yeah.
doesn't-
I thought that this was the case of the. Sure. Oh, okay. All right, good. Then do you want to share your screen just to test, like you do what you want to do?
Sure. Yeah. Does that look okay?
Yeah.
Jay, you can probably take over this place and then you can open up your Mathematica stuff, just, be in line with them.
You could be there, or you could be at another computer
Another
doing
computer?
the share.zoom.us as well. Like
Yeah, any of these lab machines you could hop on.
Well,
and
Yeah.
Jacob is
do
the boss, so he's the
Yeah.
boss.
Wherever
Oh,
he
you said
wants,
you were the person.
wherever he wants to
I'm just
sit.
helping.
That's nice.
Yeah.
So it's pretty straightforward as far as the share.zoom.us. So that way you don't have to join the meeting and have the audio issues.
Okay.
But you could join as long as you make sure everything is muted, because
Okay.
that's where you're gonna get that awful feedback loop.
But you didn't need any password to join. with
No.
Kelvin,
that.
I didn't ask you
Changed it
permission,
in the
but
settings.
is that okay? No,
Okay.
is
Change
that
it in
okay
the
if
profile
we
settings that allows
YouTube stream
people
it
to join.
or not?
So they did have. the
Sure, it's
meeting
totally
set up
fine.
Okay.
For her to do
I
that.
guess she told him, she told somebody in that
So we
meeting.
can,
You asked him if you could, but I don't think it's set up, is it?
Yeah.
I
Yes,
just
change
paused
the
it currently,
settings
so when
and
You gotta turn it on.
starts-
Because otherwise
When the
it's
meeting's
either you
well, you
have
can
to be
start it now,
authenticated
but
or there's a waiting
That's why I
area.
brought it up.
it's not
But,
relevant for now.
Or you have to allow participants to share.
I knew they
Just
were
go back.
almost done with the setup before, but the camera was flickering.
You sure you don't
Well,
I'm
want
glad
she
you
to
came in here early.
Yeah, me too. I was like, I better check
would've
just to make
really-
sure.
It probably doesn't matter.
Yeah, that's what I was
That would have
thinking.
really been terrible.
And it's hard, but it's the computer. I mean, this is a newer computer than that one, so it's kind of weird. Did I download every Dell driver that they had for this
Did you
computer?
do the Dell commands?
So whenever we're ready, we can just go live. I mean, I don't want to go live now, so.
Yeah,
that's
we're not
Windows
doing anything.
updates, I did everything.
But we can start recording just in case. Sometimes, like, like you just get excited before the meeting starts. and you
Yeah.
forget to turn it on. I'll just, how about that? And what I'm going to do is, after the meeting ends, I think this already saves it to the cloud.
If you set it up to do so.
I think that's how I did. and I'm gonna download the video, edit, and then make it available. So,
That's cool.
yeah.
It is.
Yeah, recording, yep.
It does let you know there's recording, but whether it should be recording to the cloud, you do have to specify in the cloud.
I did.
Okay,
Yeah,
then you're fine.
I'm sure I did.
Because otherwise it will do it to the local machine, which won't help you.
Yeah.
Oh.
You guys got
You want it to be in the cloud.
Yeah,
'Cause otherwise you'd have to find
True.
it on here before you logged out.
I'm sure I did it that way. In fact, all 3 events I set up already on Zooms. I think all of them are recording to the cloud. So.
Okay, good.
Well, I guess you don't have to.
I told her that you knew what you were doing with this. And I
Yeah.
think we feel better
This has
with
been a
you.
while,
Definitely.
seriously. I mean, like, we were doing that before COVID
Yes.
with Tammy and everything, so
Yes.
it's just like, I don't know.
Just put your name.
You did it before COVID, you were ahead of your time.
Yeah, but I mean, it has been like 3 years almost. This
Yeah.
is our almost first
You could
event.
teach me how to do it.
Well, and I was gonna say, you've definitely done it more than me because I come with these, and otherwise I just join it.
Yeah.
I mean, as long as the speakers, the camera works fine.
So
I mean, yeah.
the camera's always gonna be the owl and the speakers are gonna be the real time. Because it does work,
Oh.
but it won't, it
That's for,
sounds a little less,
Are you guys leaving?
yeah. Is that okay?
Okay.
Sorry.
Is there anything that I should know of before you guys leave?
Only thing I would say is, I mean, as far as problems, I mean, we went through, you logged in, you started it, so there's nothing different.
Anything to do?
So just when you leave, turn off that and turn off the computer.
Yeah.
And also, how does this?
Don't worry about that.
Don't
That's
worry
just,
about that.
that's just a USB.
Okay.
So just shut down the computer so you know everything's off, power down the projector and lock the door. Well, shut the door.
You're so helpful. Thank you so much, buddy.
Yes, I'm writing down our,
Call the 911 emergency number.
it's our student helpline, and then we're also on Slack. So if you get stuck with something and the students can help you, one of us will be able to.
That's more helpful, I think,
Sure.
for future
Yes.
reference. Yeah, test email or something, you know.
To be fair.
Calvin, we're sorry, we're just still working for the setup.
Totally no problem.
This is almost like the first time after the COVID, we're just doing this like face-to-face type stuff here in a computer lab, so we're learning.
We still got 10 minutes. So we're good.
Things seem to be working well so far. Is that a dangerous thing to say? I shouldn't say that. I'll knock on my analog wood Zoom background.
That's on this.
Yes. What?
That's the owl speaker.
Oh, it's not set on this. I thought it was.
Do we have to specify that? No.
There.
Can you speak again?
Uh-huh, sure.
That's-
Calvin
that's-
doing a test?
You may want to turn it down.
And then that's gonna be, you'll have to get into that corner. I think you, there we go. There, yeah, it was on.
Can you speak again, Calvin?
Calvin doing a test? Calvin doing a test?
If it switches again, that's how you do it. Yeah, that's where you'll get audio controls there. Because it was on the speakers.
Jacob,
There
you
was
I
listen
a
to
thought
control,
so. I know it was with
I'm
your
listening,
login.
but
I
maybe-
don't know. Maybe
Just in
we thought
case,
it
you
was
know.
that, but it was actually,
I think
when I
that-
was standing here, it's like, it sounds like it's over here. So-
Maybe we just didn't notice.
So if the eyes are on, the camera's on. There's an owl watching.
Yeah. And it's a 360, so it doesn't matter where you are. Y'all go up
As
there.
long as you're talking, it goes to the sound.
Yep. So if he goes over there, if someone is end up being up front, then it will follow them as well.
Wow.
It's pretty cool.
Is that something expensive?
$1,000.
Really?
But it is a
consider buying
microphone.
that. It's a
Microphone is
lot of
everything.
videos,
It might be worth it.
Especially when I'm standing. And sometimes I walk in front of the green screen, you know?
Yeah,
It should follow me, right?
yep, it
Yeah.
will follow you.
Oh, that's, oh, nice.
And it's got an app for it to work with your phone and stuff.
Yeah. I think if you're gonna spend that much though, maybe we could figure out if there's another one that would work better for you, because I think these are they older now?
This is, but they have newer
newer
ones. They got
ones.
newer editions of it. So.
$1,000 is good. I should probably ask for that money from the textbook company.
Well, and they've got
Yeah, purchase
webcams that'll follow too, as far as that goes.
Yeah,
So this one, you don't know what it's looking at unless you look at the screen. The webcam, it moves pans and tilts, as you want.
Do
Yeah.
you have this system already installed in library, like the new library? Like they said, like there's some rooms that you can actually.
There's one camera in 3008. It currently, I know this because we just went there today, it does not have the mic yet because it is on backward. But when it does get the mic, it will have a wireless log and a camera. So it's only the back camera, like in the back of the room. So it will show just the person at the front. It won't show.
It's a classroom still, right? Or is it a lab?
It's a classroom-ish. It was not supposed to
Can
be
you
a
record
classroom.
There's one machine.
There's just one machine, yeah.
Video recording compatible?
Sure. I mean, if you have. You could put the green screen up there, I guess.
There's affordable ones, like just pop it and.
It's just one of those wall-mounted cameras there. The pan tilts it.
So you're not, microphone's good.
Well, I don't know yet. It will be when it gets there.
I don't know, people were advertising that last year. I was like, wow, that should be something cool.
It will be cool when it's done, but everything is on back order. And that's a sure mic, so it will be a good mic. It's just not there yet. And I don't know when it will be there.
I'll check the data. How about that?
Yeah, there's a Yeti in there now that we just left. That would be what you want. That's gonna be more directional if you're standing. Not walking
Just one
around.
question, just out of curiosity. Let's say like I'm recording a talk
Right,
that I have a, let's say, PowerPoint or PDF. And let's say like we're co-presenting.
yeah,
Would it be possible with that PowerPoint in my back?
Yep.
And then two of us
Well, one of
talking
you-
into that?
one of you would need to wear the lav and the other could just hold the mic.
Oh, wow. So how about the images? Just two, all like two in one?
It is not going to follow you, but you would be able to control it manually. Well, that one doesn't have the,
Yeah, now, they're portable.
yeah.
Take it with you.
Well, the
But is
reason,
it like-
normally those rooms do have a control for the camera, but that one has a push button and I'm not sure how the camera
But how would you
is being
split
controlled.
the?
Well, you see how this,
The screen, I mean, like,
You
let's
see
say
how
like
this
this
one's
is
doing it
PPT.
automatic.
Let's say this is PPT, right?
Yeah.
You like machine learning? Oh, so we'll be doing machine learning. What if I want to bid? You just talk.
So this is 360, it's always there, but this is, so they see, so they know everybody that's in the room, but it's just the other people talking. So if I go over here and start talking, it should start.
There's way more better. I know, but they have a really big, second wall that they use, they'll go over that, it's like.
So the newer ones.
They have a Wolfram Alpha. You can ask me questions, like, there's like one, like, how many makes a little fit, like, I don't need that, I just want it. And it answers that because it has like data on it, basically, we record it baseball and like data on the tablet going. And it has like some automatic competition. Oh, yeah, no, but I think it's just like a testing set. I don't know how complex it is. We could ask him. Yeah, definitely. So you tried before? Okay. Yeah, I've shot my expertise. Yeah, I don't think it's no, I agree. I don't think
The same way as if you look at your screen.
I see. I see. I mean, I don't know. I don't know. I wish I could answer your critiques better.
But really what these
I
are
don't
about,
know
I don't know
much
what
about
the
that.
conference room was in the center, and everybody sits around,
But-
whoever talks just kind of.
And I don't even know if there's an answer to the question. Maybe their phone is different. I don't know.
But
too
they
much
use
about
all
it.
of them.
I wish I did.
Yeah.
You work with machine learning in general, right? That's what you want to work with. I started school with it.
Just Google Eyes or. He's got lots of fancy videos.
Yeah, I was thinking you had to be right. Because he's a data science person. You're right. And there's a data science lab here, right? He's in charge of that, I think. Right?
This camera, the one downstairs is
Is it just you and him, I guess? I remember him announcing it.
Go down
about a
and
year
like
ago.
show you one, or Casey can show you one of the rooms too and how it works, but I'm happy to, and then you can see if it's even, it will be better
You signed
than
into
trying to
it.
use commentary.
Yeah.
Because that one is not,
And then no one else can do it.
it doesn't have all the technology. It won't be useful without its mic.
Look, this is my job. Mine too. To purpose.
Oh, okay. Yeah, I do. I still don't think that that camera is gonna be what you want. I think it's a lower end. That room is less impressive. than that. But yeah, good luck on
Hey,
everything.
thank you so much. If you have any trouble, this guy right here.
Yeah.
He's the guy, right? Okay. Take care of him in here.
Yeah, and the students are, we have students there. If y'all run into anything, they'll be able to help you. Okay.
Thanks, guys.
Yep.
You may want to remove some of the cardboard. Looks like you're filling up good.
Let's put an X down.
I'll leave the road up here for that. I'll thank y'all.
Yeah. All right. Ready to intro probably? Luke, you want to have the intro maybe? Here you go. Podium is yours.
Yeah.
Come on, join.
I can do it.
Yeah, please.
What do I do?
I'm in a cage. Who do you think I am, a bird? No.
All right, everybody. So this is Kelvin, Mischo, and Abby Foster. They're the people from Mathematica here to give us this hands-on tutorial. And Kelvin Mischo is a certified Wolfram trainer, but also sort of a, I believe software engineer, right? Or am I misremembering that title slightly?
Sales engineer. Yeah. I'm not going to take credit or field any bug reports today.
Oh yeah, and I can help you all if you have any problems following along with the tutorial.
Okay,
If
anyway,
you want.
let's go back to Zoom again. And then you continue to your introduction.
Yeah, and Abby Foster is the coordinator for this whole thing. Not the whole thing, but helped us a lot with coordinating this. And yeah, we're just going to be having a hands-on start to Mathematica. Really, it's basically what it says. Just a nice little tutorial to get everybody in, and then we'll have some deeper seminars coming up later to get further into some more advanced topics.
And in between, if they have any question, like from today to the next UN, Jacob is the person to ask
Me, I'm the
questions.
Wolfram ambassador, so
Yeah.
it's definitely me.
So- All right.
All right, good. Thank you, Jacob. Sounds great. And I can mostly see everyone, but when I'm sharing my screen, it's a little bit smaller. So I'm not a hugely formal speaker. If you have questions or, okay, if you have questions or anything like that, please do feel free to interrupt me as we go. My goal today, so I'd imagine there's a mix of you. I'd imagine there's some of you that have used Mathematica to some extent, or you've done some things, maybe some who are totally new to it. So we are going to start with the basics today, but for those of you who have used Mathematica for a little bit, we're going to talk through kind of why it's doing the things that it's doing. It's really easy. I mean, the documentation is really great. So it's really easy to just to grab something out of the documentation and tinker with it a little bit, and then all of a sudden it works. But today we're going to delve into, sort of why things are happening the way they're happening. And then that gives you a good basis to build on, basically. So, and thank you for the introduction, Jacob. So I'm a Wolfram certified trainer. I've been at Wolfram for quite a while. I'm co-author of a couple books, but generally what I do are these sorts of things. So I've talked to a lot of different campuses. I've given, I don't even know what the number is now, some hundreds of presentations and seminars. So I just have a lot of experience where I've talked to people how they use Mathematica. Abby is on more the licensing side, so you have her to thank, where you can go and grab and download Mathematica and just use it on your personal laptop or a campus machine or 3 personal machines or whatever. It's all just very streamlined, and the idea is it just works. But if you have any questions where it's wouldn't it be nice to have Mathematica on or whatever sort of thing, Abby can help with those things. So as I mentioned, today we're going to do some first couple calculations. I'm going to have everyone type along with me. So while I'm talking here, I'm going to give a preview of next week and the week after. But while I'm talking, launch Mathematica. So double click on it and get it running, and get to the point where you're seeing a blank untitled 1 document, basically. And then I'll circle back and pick up from there. So today you're going to type along with me the whole time, though. And in fact, my plan is for you to type along with me the next seminar and the seminar after that. So all of it will be you creating calculations, you creating projects, and then you can take that and use it as a jumping off point. But we'll talk through why the calculations do what they do. And then after we've got this nice basis of knowledge, next week we're going to get into things like text scraping and programming, and spelling things correctly. But basically, it's going to be something where we're going to build some more involved projects. But then it's also nice where you can actually share these things in a web-based format. So if let me make sure I don't break this, but yeah. So next week, we're going to talk about how to do something like this, where it's a completely independent web form. And so what this application does is it goes out, you just type in any name of a Wikipedia page. It goes out, it downloads all the full text. It uses Wolfram's data to tag which of the words are actually cities. And then it uses Wolfram Alpha data to make a map, to say, okay, we know that word is a city, and so we can make a map of that, and then we can geographically visualize all these things. So I typed in the page for Ghost Town here, which is this web page. So all these nice deserted cities and things like that. So this page is not hugely long, but it's not exactly short either. Okay, this is done. So it's gone through all this text, it's downloaded all of this, and then it draws a point for every ghost town in that not article, Wikipedia page. So that's what we'll do next week. And then the week after, we're going to do some deep learning where we'll take a sample data set and we're going to make our own deep learning, specifically machine learning classifiers. Mathematica is a really, really, really good language for these kind of things, where you can do things with a very, very minimal amount of code. And that really lets your brain sit in the space of, what does this mean? And is this the approach that I really want to be taking? Not spending 3 weeks writing low-level code and you get an answer and you're so relieved that you're like, okay, yes, that must be right. Please, I hope that's right. I spent 3 weeks on it. So this is what we'll be doing. I'm going to give some sample data of quiz scores, nothing related to the campus. I made up the quiz scores, but it's the idea of, based on historical data, can we take a new student and take their performance on a third quiz and predict their performance on a fourth quiz? So I've got some raw data, couple different machine learning things. So that's a preview for the next couple weeks. So what we're going to do today is a lot of one-liner things, a lot of basics things, but these are the sort of building blocks where next week and the week after, we're going to do some real projects. Let me share a completely blank notebook then, so that
Just for
I'm
the
starting.
reference, Kelvin,
Yeah.
when you say next week, you mean next month, right?
I'm sorry. The next seminar, not next week.
Okay.
I apologize.
There's one in March and there's one in April. So yeah, just yeah. Okay. Sorry.
Thank you. Yes. Okay. So let's do a very first calculation then. So basically, wherever you see this horizontal bar here, that means that is in the notebook document. That's where whatever you're typing, that's where it's going to go in the document. So let's just do a very simple arithmetic sort of thing. So let's do 627 divided by 3. And then for those of you that have never used Mathematica, you hold down the Shift key and press the Enter key at the same time, and then it does the computation. So in your copy of Mathematica, it's going to say in 1, out 1, because it's your first calculation of the day. I have done 106 calculations, this being my 107th. You'll also notice that there are these blue brackets over here, and these we call cells. So what we're going to do is build up a document. A document is comprised of many cells. Some of the cells are calculations, some are calculations with graphics, some are text cells, some are title cells, but really what we're going to do is just build up a document that is a big collection of cells. So click underneath the 209 here where you get that horizontal bar again, and we're going to do your second computation. So let's instead do 628 divided by 3 and hold down Shift and hit Enter. And then we get the result. So this might strike you as a peculiar result where it is, you know, the input and the output match perfectly. In general, Mathematica is a hybrid symbolic and numeric system. And that's kind of rare. So if you use something like, I don't know, MATLAB or R or Excel, those are primarily numeric systems. If you use something like US or Maple or Sage, I guess, the symbolic, there are less symbolic packages, but those are primarily symbolic only. Mathematica is tightly integrated, and it is both. So if you give it something like a fraction and there is no reduction here, it's just going to give you the exact form of the fraction. So it will try to give you the exact result when it can, and it's only going to numerically approximate or chop something off when we deliberately tell it to. So keep that in mind. Also in your copy, you should see this bar here as well. And I had it minimized. So if you don't see it, there is that little arrow here. I'll do it again. So if you don't see that bar and you do see this arrow, click on that where we get this bar back again. This is something that is a really handy way to just do a series of computations, and it just builds the calculations for you, and it's context sensitive. So if we're doing something like a plot or a graph or an equation, it will give us a certain set of suggestions. Here it gives us suggestions where it says, do you want the denominator or the numerator or integer part, numerator rather, or integer part or numerical value? Let's just click on that very first one, the numerical value. And then what that does is it starts a new pair, input output, and it gives us a numeric approximation of 209.333. Mathematica, a lot of times will stick to machine precision unless you tell it otherwise, but you can override machine precision. I don't know if that's something that, that's kind of a subtle concept where either you really care about that or you really, really don't. But if you want to work with some level of digits that is beyond the normal scope of a numeric system, you can do that. It's a little bit slower sometimes, but you can work with very, very high degree of precision decibels, basically. Okay, but we're not going to get into that today. So now we've done our first computations. And let me pause there. Is there anyone who is stuck or has any just basics of getting going sort of questions? No? Okay. Okay, good. And in the physical room too, if you do get stuck and you don't want to interrupt the group, just motion over to Jacob and he can hop over and help you as well. Okay, so let's make this a more interesting document. So click above this 627/3, where you've got this horizontal bar. It's adjacent to the top menu here, but click there and then click on the Format drop-down menu, which on my screen you probably can't see very well, but click on Format drop-down, Style is the first choice, and then choose the very first choice, which is Title. And then when you do that, a new cell appears, and we can already see that the font of it is much bigger than the rest of it. So these text cells are meant for having a nice, just default formatting. So let's type in hands-on start to Mathematica. And that's our title for today. Notice it's got its own font, it's got its own color. There's our graphic design department is a really sharp group of people, actually. So the coloring and a lot of the graphics and things are done by people that are much wiser than I at these sort of things. But this is a title cell. So let's click between these two things where you get the horizontal bar. And in addition to the Format drop-down menu, you can click on this little plus thing here. This is the Cell Insertion Assistant. So click on that thing, and we've got a couple choices here. But let's click on plain text, the second to last choice here. And that also creates a new cell. This one seems to be roughly the size of an input cell, but it's not meant for calculations. It's just meant for text. So just type in any text here, like this is example text, where we will later talk about arithmetic and graphics, something like that. I just wanted to get it where it did a word wrap there. So text cells are like that, where they're really good for paragraphs. They feel like, you know, Microsoft Word or whatever. And so now you can see that we've got an outermost cell, we've got this cell, we've got that cell. You can double click on the outermost cell, and that minimizes the content. I was doing that before with the outline, where I had a couple different section cells and I was just clicking to then reveal that information. And people do that a lot when they're doing presentations in Mathematica. Okay. Now let's switch gears here. Let's do another calculation. So if you scroll all the way to the bottom and click where you've got that horizontal bar, for those of you who have used wolframalpha.com, this mode is available in Mathematica as well. So the Wolfram Alpha mode, it is the same engine that Mathematica has. So it's designed to do the same types of calculations, but it's got a big natural language processing layer that we've custom built on top of it. We're not using ChatGPT or any sort of fuzzy, maybe inexact natural language processing. It's something that we've built, and it's something where it knows what it knows very well, and it knows what it doesn't know very well, which is actually turns out to be extremely important. But with this horizontal bar, instead of just typing some command or number, type the equal sign first. So when you start a input cell with equal sign, that enables this Wolfram Alpha mode. So in Mathematica world, Mathematica uses a language called Wolfram language. It has a syntax, we'll get into that, but you have to get the syntax right. It's very useful, but you do have to be mindful of the syntax. This Wolfram Alpha mode, you can be very loose with your phrasing. You don't have to capitalize things. It's just designed to really take conversational, everyday English and turn it into something computable. So let's do that. So let's do graph of sine of x over x, and then hold down Shift and hit Enter. So now what we've got is our original calculation. This mode also tells you, by the way, here's how you would do this in Mathematica. So there's a plot command built into Mathematica. And if you're going to use trig functions, they're capitalized in Mathematica. And there are these square brackets that are used. So already we're learning a bit of Mathematica, but then we get the actual plot here as well, which is useful. Scroll down all the way to the end, or just start typing equal sign again. Let's do something numeric. So let's do pi to 1,000 digits and hold down shift and hit enter. And so now we see that there's a built-in function n, which is a numerical approximation of pi. Pi is something that is a built-in symbol in Mathematica. So when you say pi, it's not saying, oh, great, that's 3.14 or whatever. It is pi, the algorithm, basically. So what we're saying is take that built-in algorithm, that built-in concept, and approximate that to 1,000 digits, and then we can get that. You can also go back up here and edit this. So instead of 1,000, if you want to do 1,000,000, you can do that as well, and it gives you 1,000,000. It takes you longer to scroll through these and actually read them than it does for Mathematica to calculate them these days. But you can see by the scroll bar, everything is, it prints this huge thing to the screen. Let's, for the sake of brevity here, change this back to 100 then. So if you're typing along with me, change it back to 100 or 1,000 or whatever we did first of all. Let's also, before we go on, let's save this document. So like me, you probably have an untitled -1 up here. That means that this document is unsaved. Click on the File drop-down menu and choose either Save or Save As. And then you can give this any sort of name that you like, Mathematica, Hands-on, Seminar 1, something like that. Keep in mind that Mathematica does not auto-save, so every once in a while, it's not such a terrible idea just to resave as we go here. We're going to progressively be building up a larger and larger notebook document with all these examples. But then when you save it, then you'll have it as a handy reference for later. Okay, let me pause for a second. Does anybody need a minute or two to save?
I have a question about the saving because it looks like it's putting it in some users folder somewhere. I guess I'm not exactly sure where this is being saved on the computer in the lab.
Oh yeah, actually I didn't think about that.
It says it's got my net ID.
Maybe personal folder.
I have access to my personal drive now, but I'm not sure that's where this is. Sure where this will be.
Maybe browse and maybe try to find it. Maybe.
I can
Like that.
put it in another place. I can actually.
That's how I do it in a classroom.
I could just put it on my P drive and then I can find it. I just wasn't sure where it got on this computer, where it was later when
That's a good
so
question.
that's what I'll do. I'll just put it on my personal drive.
Okay, for anybody who if you're in the computer lab machine and you do end up losing this notebook, just reach out to us and we'll give you a copy of it as well. Because I've got another copy with all these inputs. So if you do happen to lose it, just reach out to us and we'll email you a copy.
Okay.
Okay.
I have another question here. Is you inputted the graph of sine x over x. I tried out some other words, right? Like get the graph of sine x over x. It also works. So and also I also wrote please give me the graph of sine x over x. It also works.
How nice.
So it's like it seems like Mathematica understands the natural language, right?
It does, yeah, it does, and especially mathematically oriented natural language. But yeah, that's absolutely right. So if you say plot sine of x, it does it. You can even be a little bit messy here where you say sine of x over x, that might be a little much. No, gosh, I don't even know if that should work, but yeah, it's very forgiving, even when you forget parentheses or things like that. That, by the way, is why it's useful also to have this interpretation here where you can see how is it interpreting sine x over x. Is it because if I say this, that's totally different, right? So that now it's a variable s,
Oh,
just a general variable
beautiful.
s, and then x over x, but it's doing a surface plot. So it's saying, well, you're using two different symbols there. So obviously you're not using x and y, but you mean something like x and y. And so it's a surface plot. Whereas then if you say something that it knows, okay, I know that SIN is not just a general symbol or variable. I know what that means. So yes, it's extremely sophisticated. It's surprisingly so. Our developers watch the logs, and they're actually most interested in the things that don't work. But they upgrade this parser every week, actually. So even something last week that it might have been a little too loose for it. It does work. But yeah, that's a very good observation. Yeah.
And Kelvin, did you say that this is the Wolfram Alpha outlet, right? So if we tell students go to wolframalpha.com and then just type this in, would that work again over there online?
It will, yeah.
Wow.
It's the same natural processing. It's the same natural language processing layer in Mathematica versus on the website. The advantage in Mathematica, on the website, you can do one thing and then you do the next thing, but it's like one-off calculations. There's only one input bar. Whereas these notebooks, we can start to do a bunch of different things and you can save your work much more easily. So they're just logistical advantages for it being in a notebook.
Thank you.
But yeah, it's all the same underlying stuff. All right, let's do a couple other things. So scroll to the bottom and, oh yeah, I'm sorry, go ahead.
How's this graph working? Because we're dividing by 0 there and it's going through 0, 1. So how's that going through 0, 1 when we're dividing by 0 for x?
Yeah, that's a good question. I have wondered that in different contexts myself. Sometimes, so in the language, you can have it show discontinuities or you can have it label that a little bit, but in this case, yeah, I don't know. It's not doing I think what you're asking is why isn't there like a circle or something there? Yeah.
At 0, 1.
Like in the calculators, right?
Dot there. It just looks like there is a dot. You can take the limit as x goes to 0, it is 1. So yeah, so
Yeah.
it's not like you see it, right? You see, we can not see it, but at point 0 is not defined. But both sides it goes to 1, right? So it goes to 1, very close.
So because it's an iteration and it's doing a step function to get there, it's just gonna be a hole there and the rest.
Yeah, I would say so.
I'll give you that.
Uh-huh.
I'll give you that.
Yeah, it does understand the concept though. So if you say sine of x over x, where x equals 0, I'm sure it will, yeah, it will say indeterminate.
Yeah,
Uh-huh.
because we had to prod it a little bit there.
Right.
Yeah, there's in the actual language, there's an option to make that, to draw a circle and to make that more obvious, I think. I just don't personally know a ton about that.
That's fine. That's fine. Thank you.
Sure. Any other questions before I? Okay, good. All right, let's do a couple other things then. So if you scroll to the bottom and get the horizontal bar, let's do, so type equals, and then let's solve some equations. So let's do solve, and then 2x minus 7 equals 0, and 3x minus 2y equals 0, and we're going to solve for x and y. And then hold down Shift and hit Enter. So the solve command is built in, but it's got a couple interesting pieces to it. So you'll notice that there's a double equals there. So single equals in our language is variable assignment. So if I say a equals 0, whenever I use the symbol a, it's going to swap in 0 in the calculation. Double equals tests equality. So if I say, does 5 equal 9? It says, no, that's false. So double equals is used with solve because we're not assigning a variable, we're testing equality. But that's a useful thing to know as well. Let's do something that's a little more data oriented. So hit equals, and let's do image of Albert Einstein, and hold down Shift and hit Enter.
Really?
So in addition to math stuff, there is a bunch of socioeconomic data, financial data, data on famous people, especially famous scientists. But this notation here is what we call entity. It's the entity function. So this means that Albert Einstein is a known piece of data in the system, and we can start to query things about it to get other things about Albert Einstein. And at this point, let's make the transition into then Wolfram language. So we've got our picture of Albert Einstein. Make sure the horizontal bar is there. In this case, though, do not type the equal sign first. We're just going to type a straight Wolfram language built-in function. So it's called facial features. So type capital F, facial, and then capital F features. And you'll notice there's a drop down there where there's some command completion where it says these are all the built-in functions that start with facial F, of which there is one. And so you can keep typing or just click on that. And then type open square bracket. And you'll notice it makes a open and close square bracket at the same time. And within there, type the percent sign. Percent sign in the language means the last output, not the last output on the page, but the last output in terms of the last one you calculated. And then hold down Shift and hit Enter. So in addition to math stuff, there is a lot of supervised and unsupervised deep learning, machine learning. This is one of them. So I think this is probably based on some neural net where it takes this picture, it compares it to likely millions of tagged images, and it says, okay, based on all of those data points and whatever we can extrapolate from that, the prediction is that this picture of Albert Einstein is 51 years old, gender's male, and emotion is happiness, which seems about right. I've shown this example a lot of times. I actually don't know how old he is in this picture, but it seems ballpark right. This, however, though, is Wolfram language input, where you'll notice that this does have to be kind of exact with the function name and with these brackets and stuff too. All right, so now let's do more Wolfram language stuff. We're going to use that little, we did a numeric approximation before. We're going to use that again. We're going to start though with a mathematical expression. So click on the drop-down menu at the top, the palettes drop-down menu, and choose the very first one, the basic math assistant palette. And when you click on that, this new palette will pop up. I hope you can see that on my screen. Can you see the buttons on my screen?
Yes.
Okay, good. So this will pop up on your screen. And that's, in a nutshell, that's all these palettes are. They are buttons where you can put in nicely typeset formatting or math formatting. So things like pi or square root or fractions or whatever. What we're going to do, though, is if we go to Advanced, click on the Advanced tab, we're going to use this indefinite integral. So make sure this horizontal bar is below the Albert Einstein and click on this button right here. And that's going to paste in a nicely typeset indefinite integral sign. And it's got two placeholders where it wants an expression and then a variable with respect to whatever the variable is. So in expression, type parentheses, -10 plus, and then x. And you can either do the shift 6 to do a caret, so x squared that way, or you can do control 6 and do squared that way. And if you do the control 6 with the squared, then you press the right arrow to get out of the superscript into normal formatting, and then a closed parentheses, and then hit the tab key, and we want with respect to x, and hold down shift and hit enter. So there is a built-in command in Mathematica called integrate. So integrate open square bracket equation comma x, which is respect to x. But a lot of times you want to mirror the typesetting in your textbook or just do this for readability. So this typesetting, especially for math stuff, is really nice. It's really useful. But let's do a few more things in the suggestions bar. So now that we've got this, this isn't a fraction, it's an actual equation. So let's do something where, I mean, we could plot this or simplify it. Let's do a factor of this. So if we press that button, then it takes that output, which is an equation, and it factors it, which is partially useful here. And then click on the plot button. A lot of times what we want to do is do some sort of calculation and then plot. So if you click that plot button, then it uses the proper plot function with the brackets, our factored equation, x going from -13 to 13, and there are heuristics and sort of logic built in where it tries to pick a really nice domain and range for the plot where you can see it pretty well. Okay. So everybody with me so far? Okay, good. So the next thing we can do, and I've got to evaluate this again to get that bar back, but at the bottom, there's this button called Rollup Inputs in the suggestions bar. And go ahead and click that thing. What Rollup Inputs does is it takes everything that we just did, so the factoring and then the plotting, and it makes one compact calculation. So you can think of Mathematica like a bunch of built-in functions where you can wrap one function around another, around another, around another. It's sort of like f of g of x. So it runs the innermost calculation first. I mean, in this case, the plot's going to look the same, but it runs factor first, and then it runs plot, and then it gives us that plot. If this were integrate, right, sorry, this is the integrate. So it runs the integrate first, and then the factor, and then the plot. So it's giving us the integral of this function. But this is something that's really useful, generally speaking, where you'll often want to do this, where you wrap one command around another, and we'll do this more in the next seminar, not next week, next month, but the next seminar, we'll do a lot more of this kind of stuff. Okay, let's next define a couple variables, and we'll go through this kind of quickly, I think. So let's define, and just click where you've got this horizontal bar again. So let's do a equals 7, and then put a semicolon after it. And I'll explain what this does in a moment. And then don't hit Shift Enter, just enter. And so what that does is it just does a carriage return. So it doesn't evaluate a equals 7. It just gives us another line where we can do a second computation. So then let's type in b equals 3 and a semicolon, and then hold down Shift and hit Enter. So what semicolon does is it runs the computation, but it suppresses the output. So we've globally defined A as 7. We've globally defined B as 3, but we've suppressed the output. If you're doing data science or data analysis, sometimes you'll want to say A equals all the text of a Wikipedia article. Well, you don't want to print that to the page. You probably just want to scan through it or do something with it. But that's why the semicolon is pretty useful. Now let's do another calculation. Let's do A divided by B and hold down Shift and hit Enter. And then it swaps in the value for A, swaps in the value for B, and then we get a result. So pretty simple so far, but A could also be a list. So let's do another variable. So we're going to say A equals curly brackets. So that's Shift, the button right next to the P. And then let's do a list. So it could be a list like a data set or a vector or something like that. But let's just do 1, 2, 3, 4 and hold down Shift and hit Enter. So now when we say so notice first we get 1, 2, 3, 4. So it's confirmed we have redefined A. Notice also that this does not change. So the various inputs and outputs only change when you reevaluate them. So if we go and do a new calculation, A over B, and evaluate that, now it's got the new value of A. So it's going to take the first element and divide it by 3, so 1/3, the second element of the list and divide that by 3, and so on through the whole list. And so what we get is another list with 4 elements in the list. Many of the functions in Mathematica are what is called listable like this, where if you're working with a data set, doing data analytics, and you just run some sort of function, a lot of times it'll sort of automatically run on each element of the list, which is exceedingly useful in a lot of cases. But anyway, I just wanted to show you when we've defined this and now we've defined this statement overwrites that statement. So even though it doesn't look like it on the page, the current value of A is this updated value. I want to do one more thing with lists before we move on. So type this or click where you've got the horizontal bar, and we're going to use the table command. Table is an extremely useful function in Mathematica. It does what it says it does. It makes a table of values. So let's do T equals. So we're going to save the results as a new, under the symbol T. And then let's do table with a capital T, open square bracket, I squared, or you can use control where it's I squared, and then right arrow to get out of that, comma, open curly bracket, and then I, comma 1, comma 5, and then the other brackets are already made for you, but you could just say close curly bracket, close square bracket, and then hold down Shift and hit Enter. So now what we've got is this table calculation. So table is a looping function. So I is the iterator, the min value is 1, the max value is 5. So essentially it says assign the value of 1 to I and then square it. And then it chooses a step size of integers. So it says assign I of 2 and square that, assign I 3 and square that, and so on, up to the max of 5. If you want to give it a different step size, you can do comma 0.5 and reevaluate. And then it's doing I going from 1 to 5 in steps of 0.5. So you can let Mathematica choose. It doesn't always choose integers, or you can choose the step size yourself. But in any case now, T is stored as this result. So now anytime that we use T, so let's do a list plot. So type in capital L, IST, and then capital P, LOT, open square bracket, T, and hold down Shift and hit Enter. So now anytime we use T, that is this list, and then we can do a list plot of that list of squared values, and then we get that. So defining variables is really useful. Sometimes you wrap a function around a function around a function. Sometimes you can, if you have sort of one thought and you want to store that with a symbol name, and then you do a second step to a calculation, you start with that symbol name and then do sort of the next series of things and store that. So it's up to you stylistically how you want to do that. When I see Stephen Wolfram write code, he hardly ever defines variables like sort of incremental variables. I do it all the time because I'm not as smart as Stephen Wolfram. And when I look at something 3 months later, I think to myself, ah, yes, that's right. This was sort of my import step, and this was sort of my data cleanup step, and this was sort of my statistics step, but I'll, sort of chunk them each differently. But it's a stylistic thing, not a syntactical thing. Okay. Let's move on to models and animations. So there's a function in Mathematica called manipulate. And what manipulate does is it draws a slider where you can vary some parameter and it recalculates the result as you go. So for any kind of math sort of oriented problems, that's really useful. It's also really useful for data too. So let's start typing in manipulate. So type in capital M, A-N-I. And so at this point, we can see there are only two possible built-in functions that start with an M-A-N-I. Click on the first one. And then after you click on it, you'll see this double down arrow here. And click on that next. So there's command completion built into Mathematica, where for this particular command, there's several different types of ways you can use it. And this is just all the syntactical variations. We're going to choose the very first one. So click on this manipulate expression, comma, umin, umax. So if you click anywhere there, then it completes the expression. It does the brackets for you. And then, we're ready to fill this in. The thing that we're going to use to fill this in is actually something that we were doing above. So scroll up a ways, up to that plot sign of X, this thing, and click on this output. And that gets rid of the freeform input, the Wolfram Alpha part, and it's just a regular computation now. Highlight the whole thing and copy it. You can either do that with the edit drop-down menu copy or the keyboard shortcut, which is Command C. I think on both Mac and Windows, Command C. But then once you've copied that, go down, click on this EXPR placeholder, and then do paste. And so it's going to paste in that plot sign of X over X. We're going to modify this where instead of plotting sign of X, put your cursor in there right next to the X, but after the bracket. And we're going to say FREQ space X. So FREQ times X over X. You'll notice this X has a slightly different coloring than that X. So this X is, it's a variable specific to the plot. This one is a little bit of a darker blue, which means it's an unknown symbol. We haven't defined anything for FREQ. Click on U, we're going to do just that, and put in FREQ there, and then hit tab, and then let's do 1, and then tab, and then 20. And then hold down Shift and hit Enter. So now what we've got is a plot of, we're plotting sine of FREQ times X over X as FREQ varies from 1 to 20. And so as we increase this slider or decrease this slider, it just replots this in real time. And we can hit this plus key and play this like an animation. We can slow it down or speed it up or have it loop backwards or forwards or we can type in a specific numerical value here. So if I type in, I don't know, -5, something that's not defined on the slider, it will do it. It draws the slider, or it draws the graph where FREQ equals -5. But then we get this notation that says, hey, I've done this, but we're off the lower bound of the slider there. I'll pause there for a second. Does anybody have questions, or is anyone stuck?
Yeah, we did have one issue. It seems some people were having issues with the equal sign and then the freeform input that comes afterwards. That it's not running. It takes all the commands as not having an interpretation, even though they're copying the exact thing that you wrote. The person was on a Mac, by the way. That is like now.
Say the middle part. It's saying there's no activation.
Yeah, like essentially, it's like not. It says it gives an error like no interpretation available or something like that. Like try a different sentence.
Oh, weird.
I can look at the exact message.
Yeah. Yeah. I don't know that we're going to be able to troubleshoot that in real time.
Yeah, it just says no interpretation available in parentheses. That's exactly what it says.
Interesting. So the freeform input, it is going out over the internet and hitting our servers. It might be that your campus, like in the computer lab, the web traffic might be locked down. It might think that you're doing something outside of normal website kind of stuff. Is it happening for everybody or only certain stations?
I have a Mac that works.
It seems that they're getting. Okay, here I got this one. Yeah, no, I don't know. It seems pretty isolated. But for those people, they can't really follow along with those parts, so maybe it'd be better to be lighter on them or to give.
Okay, yeah. We're going to do all Wolfram language from here on in. Okay.
Right, that's it.
Okay, thank you. That is weird though. Okay. All right, let's do another example. So instead of retyping this whole thing or modifying it, and if you haven't saved in a little while, you could resave as well, but highlight this whole thing and do the Command C or the edit drop-down menu and copy, just to copy the whole thing. And then scroll down and click below the last manipulate output and just paste that in. And we're going to add to this. So instead of doing one slider and one trig function, we're going to do more of each. So put your cursor right behind the curly bracket, between the curly bracket and the square bracket there, and type comma. So we've got curly bracket FREQ 120, close curly bracket for that list, comma, open curly bracket. And then we're going to do another function called max, comma, and let's have max go from 5 to 15. And then arrow right or hit the close curly bracket. And then let's do another comma. So we're going to have a third thing here, open curly bracket. And then let's type in FUNC, so just a new symbol, and then comma. And in this case, instead of doing a lower bound, upper bound, we're going to do a list of choices. So another curly bracket. So this is a list of lists. And then we're going to type in the list of sine with a capital S, comma, cosine with a capital C, comma, tan with a capital T, and then, and that should be good. And then let's go back and edit this. So instead of sine, replace the sine with a capital S with func. So we are plotting func of frequency times x over x as x goes from -9 to, and replace this 9.4 with max. And then hold down Shift and hit Enter. So now we've got all sorts of things. We've got our frequency that we had before. We've got max, which redraws the x-axis where it slides the viewer for us. And I'm sort of purposefully keeping this input there and chopping this off a little bit just so you can see the input. But if we click on tangent or cosine or sine, it swaps in that trig function, and all of these things still work very nicely. So these sliders can be multiple things or multiple tabs or all sorts of mouse-driven controls, which is pretty cool. All right, how are we doing on time? Doing okay. Okay. Any questions on that before I move on? Because I'm going to switch gears totally to data analysis.
So can you please go in to the Einstein image?
To the Einstein?
Yes, Einstein image.
Uh-huh. Yeah.
Okay, for this one, I mean, which library you have used? I mean, which library Mathematica using to generate this image, and why only this image, not another Einstein images?
Yeah, that's an extremely good question. So this data is deliberately and manually curated by us. So if you ask for the mass of Jupiter, we have compared multiple data sources, and we've built in what we feel like is a vetted, good, reliable value. You're right, for an image of Einstein, there's a lot of possibilities. I don't precisely know where that one came from. In the documentation, a lot of times there is source information for this data. In this case, if we click this plus key right here, that also might tell us the source data as well. No, in this case, it does not. In this case, it does not. A lot of times these are in the documentation, though, for something that you'd want to cite or specifically know where it came from. But I'd imagine that this is either from, something like Wikipedia or something like that. But it's something where we just built in what we felt is the most iconic image.
So Mathematica using any sci-fi or simple ITK behind this algorithm, or these images is directly generated for the Google. So which one? So I mean, is it working with the OpenCV scikit image or simple ITK, something like that?
I don't know enough about the back end to answer that. It's something where, so this data comes from either just the open domain, or it's something we pre-compute, or it's something that we buy. So like if you ask for, let me just do this really quickly, like the price of Apple stock from Jan 1, 2021 to today, or something like that. So some of these things are things that we actually buy. The image of Albert Einstein, I imagine, is coming from the open domain, and we just chose one that we feel is sort of iconic, or maybe there's a common data source that we found for pictures. I really don't know, but this one is one where this is coming from a very specific spot. Used to be Yahoo Finance. It's not anymore. It's another one. I've forgotten what it is. We just switched, but usually it's coming from somewhere where we can cite it and tell you where it came from.
Okay, thank you so much.
Yeah. Okay, let's do a little bit of data analysis then. So let's scroll all the way to the bottom here. And we're going to import a data set. So start a new, so click where you've got the horizontal bar. Let's do a variable called data. So we've got it. Well, let's see, I've already got a data today. Let's do data2 equals, and then we're going to use the import command. The import command is the way to bring external data into Mathematica, whether that's an image or a spreadsheet file or an audio recording or some markup language like a web page, import's really handy. So capital I, import, and then do open square bracket, and then quotes, because if there's a string of text, there are quote marks around it. And then what we're going to do is type in a URL here. So this is going to be http:// www.handsonstart.com/example with a capital E, data, capital D, scores, capital S, .txt, and hold down Shift and hit Enter. So what we've done here is we've imported a text file off of the web, and we can see here that this is some sort of tabular data where it's a first name, a last name, and a number. One handy trick here. So if you wanted to import this as text, so let's do the next calculation. Let's type in string length, capital S, capital L, open square bracket, data 2, and hold down Shift and hit Enter. So if you mean to have this as a string, we can measure how many characters are in the string. So this is telling us there are 82 characters in the string of text. In our case, though, we want this to be a data set. So let's copy this whole thing. So highlight it, copy it, and scroll down and paste it underneath there, and change data 2 to data 3. And after this quote, type comma, quote, data, and hold down Shift and hit Enter. So you'll notice that this looks much different. So this now has extra brackets. So we can see, like if you picture this in Excel, this would be the first row in Excel. This would be the second row, third row, etc. And then there are 3 columns of data. So we've got a nice summary there. Let's extract some of the data. So the part command in Mathematica is really useful. So capital P part, open square bracket, and then let's type data 3, and then comma, and then we want, let's say, all rows with a capital A, and then comma 3, so it's all rows, third column. And when we run it then, that just gives us the numeric information at the end, and it omits the first name, last name, which is pretty handy. Now, now highlight this. So let's highlight and copy this. And let's do another command, list plot, which we did before, capital L, capital P, LOT, open square bracket. And then within those brackets, let's paste that in. So now, first what it does is it takes our stored data set, it takes the all rows third column of that, and then it does a list plot of that resulting list. And then we've got a scatter plot of these scores from these people. But the part command is really, really, really useful for sifting through data and for getting pieces of data and for projects. So the next 2 seminars where we're delving into a project will make heavy use of commands like this, especially when we're working with data. Okay, let's end there. So if you want to save this, if you're not on a public computer lab machine, you can save it. The other thing that you can do instead of saving is you can publish a notebook as well if you want. So when I click on the File drop-down menu and then Publish to Cloud, this is a mode. So if you save this, it is a file where you're running it on your machine, or you can email it to someone, but it opens in Mathematica. Publish to Cloud means it creates a read only, except for those sliders in the manipulate, which are live computations, but it makes a really nice publicly accessible version of this. So if you can specify a name, you can password protect it, but if I just choose the defaults and say, yes, publish this, then it says, great, I've taken your local notebook, I've put it on Wolfram servers, I've assigned you this URL. So it's wolframcloud.com/obj/kelvinm, which is my login, and then it's kept my same file. And then if I go to view that, I can go back to the web browser here. And so it's opened this up where this is wolframcloud.com published, and this is all of what I just did. And so when you're doing projects in Mathematica and you want to share things with colleagues or other researchers or friends or what have you, when you publish a notebook, this even looks pretty nice on mobile. It looks really nice on an iPad in a browser. But if you've just got an idea and you want to send it out to people and say, hey, take a look at what I've done. Do you have any comments? What do you think about this? They can either read and respond to you, or if they're in front of their machine, or if they've got the cloud version of Mathematica, they can either download this and run this in their Mathematica, or they can make their own copy and run it in browser as well. But I will end there with that sort of sharing layer of Mathematica, which is a newer, that's a whole new world for us, where for a lot of years people were just making notebooks, they were on your machine. Maybe they would take just a plot and save it as a JPEG or something like that and put it on a website or put it in a paper. But publishing a whole notebook, I thought it would be useful, but in practice, it's really, really, really useful. I mean, not to mention that I can go in the chat of this seminar and just put in the published notebook, and then you can click on that and just see everything precisely that I've done. And so if I did a couple things a little bit too fast, now you've got an exact copy of what I've got as well. So anyway, I will end there. Are there any final questions before we wrap up?
Any questions from the Zoom people, by the way? So like, we don't want to look like we ignore them or something. But any questions from the Zoom people at all? Just simply unmute yourself and ask.
I guess how can we keep progressing from here until the next month of the webinar, so I get some additional practice in?
Yeah. A couple suggestions. I would say, and it depends on your background and what you want to learn. But I would look at the Elementary Introduction to Wolfram Language. It's an online book. So if you just do a Google search for Elementary Introduction to the Wolfram Language, this is Stephen Wolfram's most recent book. It covers all sorts of topics. So some of the stuff that we went over today, like the very first look at lists or making tables, or some of the things from today. But there's a lot of other things that he's going to get into that we won't have time. The other really nice thing, though, is that if you go to each one of these chapters, there are several examples that you can just read through. And then there are end of chapter exercises. Where are they? There's a Q&A, tech notes. I think I've just gone right by it. Exercises, here it is. This is what I'm looking for. So here's a question of make a 12 by 12 multiplication table. And if you click on that, this is the expected output. And you can click on this, and it's going to ask you to log into our cloud. So you do need to have a Wolfram ID. Oh, that's fascinating. Okay, but then you can write your own code here and then check your solution. So if my solution is this, and I check it, it will say, obviously, you are completely incorrect. Yeah, but if I say something like table of, what is it, 12 by 12 multiplication table? How do you do that? So it's I times j as I goes from 1 to 12 in steps of 1, j 1 to 12 in steps of 1. Does that seem reasonable? Yeah, I don't know. I can't remember what the original thing was. Let's see if I'm right. No, I'm not. I don't remember the question, or I don't remember the expected output, obviously. But this looks at your output, and it's really good for practice like this, where it forces you to think through this yourself and write down a few things, which is really handy. That's what I'd suggest. I'll put this in the chat too.
Very cool.
I have a book as well myself, but it's something that is for sale on Amazon. So I'm recommending this over my book solely because it's free. I personally think my book is equally as good, but I'm sticking to free things today in the spirit of a free seminar.
Can you ask another question?
Yeah, go ahead. Yeah.
Professor, can you please go to the TXT file on the board?
Go to which, sorry?
The TXT file that you generated the code for the data to.
Okay, yeah, the TXT file. Let's see. Yeah.
Okay, so here we will generate this TXT file for our data sets. Suppose we have now 15 rows and some of them are missing values, non-values. So artificially, can we generate these data sets by the code in the TXT file?
Say that again. Can you generate it yourself?
I mean, right now we have 1, 2, 3, 4, and 5 rows, right? Now, if we have 15 to 20 rows and some of them data are the missing, that is non-value. So right now, and we have to work with that. Some company give us the data set, but we cannot ignore this data, the missing data. So can we generate these null values in the TXT file?
I see. Okay. So the next seminar when we meet will be a much, much better answer. The short answer is yes, and there's a wide variety of ways to do that. I think in some cases you might want to just extract data or just omit data. So let's say, I'm not going to do this in real time, but let's say the second column was completely missing. So you could do all of the data and just the first and the third columns. So let's say these were all just blank and you just wanted to get rid of them. You could just say part of data, all rows 1, 3. The other thing that you can do is if there's data and there's missing values, but there's something in there like not applicable or just something kind of weird, like a weird character. So when you import that, that usually imports as a string of text. So that would be like a missing value. There's another layer to Mathematica, which is a really powerful pattern matching layer. So if I say replace all of this list, and I say wherever you see NA, make that nothing. Oops, and you need a so I've gone this long and I've not made a syntax mistake. Okay, so if you make a syntax mistake, notice that I tried to evaluate this and it's basically telling me here, you've got an open square bracket, but no closed one. And when I fix that, it turns black. Anyway, that's a good lesson, but this would be another for missing data. So if it's interspersed in the column, then you can do pattern matching and just delete it or get rid of it. You could also say, whatever the averages of all these should be that value, or, there's all sorts of descriptive statistics built in, but, for missing data, there's a lot of different ways to approach it, I think.
Thank you so much.
Sure. Yeah. And of course, well, yeah, I don't want to get in this today, but the other thing that we're going to get into in the next seminar is using Wolfram Alpha data really to kind of double check and vet the data that you've got. So like if this data is Bowling Green, but it's not capitalized and it's not really clear what that is, you could write a loop, you could write a table function that just says, I sort of expect all those things to be a city. Tell me which of them are actually cities and which are things like bowling nowhere, which is obviously just sort of like bad junk data that you want to get rid of. So you can just strictly filter based on patterns, but the Wolfram Alpha data and the existence of this data being built in where you can mix and match things, it is surprisingly useful in a lot of ways. Like to me, I think to myself, yeah, that's probably useful. But then, 3 years go by, and I think of it yet another way why it's useful. So it's something where it's always useful for whatever you're doing at the moment.
All right, one final question. I think we are supposed to be done. It's already 5:12. From Zoom people or from here, from the audience, any question?
Where it is we used Mathematica for data analysis currently in the industry, why it is used coding with Mathematica?
I got the first half of that, not the last half. Did you say for Mathematica in data analysis in industry?
Data analysis or
Is there any specific reason why Mathematica is not used in industry as far as he knows?
Oh, yeah. Okay, so that's a question, and I laugh because there's kind of a long answer to that. So there are a couple answers. First is that there are actually a lot of pretty famous people in industry that do use Mathematica. Like the author of the Black Swan books, the Nassim Taleb, the financial risk person. Hal Varian is a big user, the chief economist at Google. There are a lot of people that use Mathematica in industry and use it well. I would say for data analytics these days, people are comparing us and Python and R and Excel and all sorts of stuff. I don't know. I mean, I don't have any like statistics about which one of those is most popular these days. People certainly talk about Python a lot. People are starting to talk about Julia now too. I would say people do use us a lot. I would say when I talk to people in industry, we're actually most commonly at the prototyping stage of a project. So in a lot of ways, people will say, I've got a data analytics idea. I think it should be an interesting result, but I'm really not sure. I'm not quite sure what to expect. So I just want to try this, and I don't want to take the time to write it in Python for a week. I want to prototype it in an afternoon in Mathematica. And then if it works out, then maybe I'll switch to a lower level language because maybe that's what our IT people use for their dashboarding stuff, or maybe I'll switch to Tableau and do something where it's got a interface, but it's very commonly used in the prototyping stage. So first, that means that's kind of the pre-invisible step where that doesn't get published or shared or talked about a lot. And so I think that deflates the perception of how much Mathematica is used in industry. I mean, we have just as many people running around working with companies as universities to do licensing stuff. And our consulting group is growing as well. But I would say that's probably why. It's because familiarity, where somebody might be more familiar with Python, but B, it's used for a lot for prototyping. And even if somebody is also a Python user, those are not mutually exclusive, I would say.
All right. Thanks, Kelvin. That was a wonderful presentation. Oh, I'm just looking forward to the next event, which is going to be on March 24th. That's going to be Friday, by the way. The next event, that's going to be from 4 to 5. We will be here again, the same setup, same everything, so you can bring your laptop. And then the project is data analytics, right? That Kelvin, right? Am I right?
Yes,
okay.
Yes. Yeah.
And then there's going to be another one. I think Kelvin advertised that in the beginning, April 21st. That's another Friday. Same time. That's going to be more like on deep learning applications of Mathematica. All right. So Let's end here because it's already 5:15. So thanks again, Kelvin. So you can hear us.
Thank you. And thanks for coming.
All right. So yeah, we will see you next month.
Yep. Have a good rest of the evening, I suppose, for everyone.
You too. Bye-bye.
Bye, everyone.
Stop.